go. So this is going to be our lecture for today. So like I said, the last thing we went over is adding and subtracting mixed numbers. And the key was just like any other problem. First thing you want to look for when you're adding or subtracting fractions, regardless of the type of fraction, do you have a common denominator? And if you do, great. So here's a situation here where we did 3 and 4 ninths plus 2 and 2 ninths. Hold on one second. My cat is gonna. I don't want him knocking over my laptop. All right, back to business. So here's a question: 3 and 4 ninths plus 2 and 2 ninths. Now the key to this was first looking at the denominators, and they were 9, so that's great. We can add these the way they look. So if I add them straight down and I put them in a column or a stacked formation, notice I get 4 plus 2 is 6 over 9, and then 3 plus 2 is 5. And you always want to make sure, anytime you add or subtract fractions, that you reduce that fraction. That's the key to this, okay? It's just reducing. So this is the first one we did. And then we ran into this situation right here with the next problem. 9 and 5 ninths plus 5 and 7 ninths. And what we found here is first, denominators were the same, so that's great. So we added 5 plus 7 is 12. The 9 stays the same, and the 9 plus 5 is 14. However, we have to remember that a mixed number is a whole number and a proper fraction. And here, highlighted in blue that I'm circling, is a whole number and an improper fraction. So, what we need to do is take 12 over 9 and convert it into a mixed number. And how do we do that? You just divide. So 12 over 9 is 1 and 3 ninths. And what we did here in the second part of the blue, down here below, you can see me circling it, is we just added the whole numbers together, kept the 3 over 9, and reduced it. Okay? Are there any questions with that? Speak now or forever hold your peace. All right, let's do another example like this then, okay? And then we're gonna get into the situation where, well, what if they don't have common denominators? How do you approach something like that? Okay. So let's see here. Let me get an example real fast. So how about 3 and 7/10 plus 1 and I need an odd number. 5. No, I don't want that one. How about 9/10? That'll work. All right, so once again, I like to stack this. So what I'll do is just stack them. Now my denominators are the same, therefore I'm going to add straight down. So my denominator stays the same. That is a 10. 7 plus 9 is 16. 3 plus 1 is 4. Okay, now, from here, we're going to go ahead and take the 16 over 10, and we're going to convert that into a mixed number. And to do that, we just divide. 10 goes into 16 once. So it looks like on the surface, we come up with 1 and 6/10. Are we okay so far? Okay, now that's 6 over 10. Remember, you can reduce that. 6 is 2 times 3. 10 is 2 times 5. The 2's reduce, so 1 and 6/10 is really 1 and 3/5. I think that's the hard part. That's the hard part. The easy part, you had 4 to begin with, and you're adding 1 and 3/5 to that, and 4 plus 1 is 5. Does that make sense, everyone? Okay? Are we all on the same page? All right. So now here comes a situation here, all right? What if your denominators are not the same? Okay? What if your denominators are not the same? Well, let me ask you this question. If these were just regular fractions and you didn't have the same denominator, how would you go about that? Any ideas, anyone?
Prime factorization.
Yeah, perfect. Stephanie, perfect. What we would have to do is find a common denominator using the prime factorization technique. So if you just want to watch and then write down, that's fine with me. I'll do one whole step and then you write it down. I'll do another whole step and then you write it down. So step one, we need to find that LCM. 6 is going to be 2 times 3. And 4 is going to be 2 times 2. So my LCM is going to equal 2 times 2 times 3, or 12. So there's step 1. So go ahead and write that down, and I'll get step 2 ready. All right, step 2, we're going to build equivalent fractions. Now, I'm not going to be concerned with the whole number. I'm concerned with just the fraction part. So I'm going to write 5 over 6. And I know I'm going to multiply it by another fraction so that I get 12 as my denominator. Now, if you remember, just watch this. Like I said, it's so important that we watch sometimes versus copying something down. So over here on the left-hand side, here's my number 6 right here, 2 times 3. So if I go into my LCM, notice you already have 2 times 3 in your LCM. The only number that you don't have is the number that I didn't highlight, which is another 2. So what I'm going to do is I'm going to take 5 over 6 and multiply it by 2 over 2. Now, if you look at this, 5 times 2 is 10. 6 times 2 is 12, which is exactly what you wanted. Now, I will do that for the next fraction. So our next fraction is 3 over 4. We're going to multiply that by another fraction so that we get 12 as a denominator. Now, once again, I'm going to use that highlighting technique so you can see where I'm getting these numbers from. It's not like I'm just making them up. So in step 1, there's 2 times 2, which is 4. In your LCM, there's 2 times 2, which is 4. The only number that's not highlighted is the 3. So I will write 3 over 3. And if you look from left to right, 3 times 3 is 9. And 4 times 3 is 12. Are there any questions with what I just did there? All right. Every single problem is done the same exact way. So now step 3, I'm going to write underneath. Only because it gives me more room. Step 3 is rewrite. And simplify if you need to. So my first fraction is going to be 1 and 10 twelfths. Plus 4 and 9 twelfths. Okay? Now here's a situation where we have common denominators, so we're just going to add everything the way it looks. 10 plus 9 is 19 over 12. 1 plus 4 is 5. Now, we need to take the 19 over 12 and convert it into an improper fraction. So all we have to do is divide. 12 goes into 19 once with a remainder of 7. So we have 5 plus 1 and 7 twelfths. And when you add those two together, you get 6 and 7 twelfths. So hopefully when you take a step back, 30,000 foot view, okay? And you're looking from down below, nothing has changed. I didn't teach like any new trick or anything like that. I didn't do anything like that. I'm going to zoom out so we can just see the entire problem. All right? We started off with mixed numbers that did not have common denominators. They had different denominators. So we found our LCM, we built our equivalent fractions, and then all we did was just rewrite the problem. We added and we simplified when necessary. Does that make sense, everyone? Yes or no?
Yes.
Perfect. Now, notice I just wrote down the same problem again, because there's another way to do this problem. Does anybody know what it is? Does anybody know what it is? All right, I'll show you. 1 and 5/6 is a mixed number, but we can convert that into an improper fraction, correct? 6 times 1 plus 5 over 6 is going to equal 11 over 6. Plus 4 times 4 plus 3 over 4 is going to equal, what, 16 plus 3 is 19 over 4. So if you wanted to, and nobody says you cannot do this, but if you wanted to, at the very start of the problem, you could have went from mixed fractions directly into improper fractions. However, your technique still is the same. We still have to find the LCM. Still got to do this. Give myself some space. We still have to build those equivalent fractions. I'm going to put BED or BEF, build equivalent fractions. So we still have to do this. So this is going to be 11 over 6 times a fraction to get 12 as a denominator. So we still got to do 2 over 2. So that's going to be 22 over 2. Still got to do the second fraction. So that's going to be 3 over 3. 19 times 3 is 57. And you still have to rewrite and simplify. So 22 over 12 plus 57 over 12 equals 79 over 12. Now, before I finish this problem, does anybody see maybe an advantage and then a disadvantage with using this method?
Leaves you with a higher number.
Jasmine, I agree 100%. Although converting it into an improper fraction may make this a little bit easier to manage, as Jasmine said, you're going to end up with an extremely large, or you could end up with very large numbers as an answer. And we still have to convert this back to a mixed number, this 79 over 12. So you got to divide. Now, 12 times 6, or better, I'm sorry, moving too fast. 12 goes into 79 6 times. The answer is 72. 9 minus 2 is 7. 7 minus 7 is 0. So as you can see, we get a result of 6 and 7/12 again, which is the same thing we got over here. Personally, it's up to you. Whatever method you like, that's the one I would really learn how to use. All right? Everybody is different, so I'm not going to force you into one type of way of doing this. That is entirely up to you. All right, are there any questions? Yes or no?
No.
All right.
Nope.
Good, good. Real quick before I go on, I just want to say something. I have been extremely impressed with the work that we've done in this class. So, we're about halfway through the semester. So, just do yourself a favor. Just give yourself a little bit of credit. You've done good so far. Keep it up. I get very good questions, through WebAssign or just the emails. So everyone's asking really good questions. If you haven't asked me a question yet, I guess my response to you would be, what are you waiting for? Ask me a question. It doesn't even have to be math related. You can say, Float, what's your favorite movie? I'll tell you. I got 2 of them right now. Jaws and Jurassic Park. They're both fantastic movies. All right? Are we ready to go on? Connor, you got a question. I can see your hand up.
I went to a movie this weekend.
What did you see?
Venom, Let There Be Carnage.
Is it good?
It was very good. I liked it.
All right, don't give me any spoilers, because that is a movie the wife and I will definitely go see.
What I will say, though, is it's not longer than the first one. That's all I'll give you. The rest of it, my lips are sealed. I don't want to spoil anything.
All right, we'll talk about it after I see it then.
Okay.
All right, so here's our next problem. Now we're going to do some subtracting. Not difficult. However, something happens here. So, Jasmine, how do you want to do this problem? It's up to you.
I guess do it the first way where we ignore the whole number until the end.
So you want me to stack them on top of each other like this, correct?
No, you do it where we would find the LCM way first, or no, because it's subtraction.
Well, my question to you is this. Are the denominators the same or are they different?
They're the same at the moment.
So I don't have to worry about finding the LCM or anything like that. Because they're the same. So now, I got 2 ways. I can stack them like this and subtract, or I can convert them into improper fractions, subtract, and then convert back. You pick.
I guess just the former.
Okay, so this way. So I like the way you're thinking. But here's the problem, Jasmine. We know denominator stays the same. It's going to be a 9. But now we have 4 minus 7.
But we have to flip it or something, so the number or the numerator's higher.
Ah.
No, I don't think we would do that.
No, I agree with you, but I love the way you're thinking. All right? So here's the issue right now, everyone. 4 minus 7, we really can't do that the way that we're doing this problem. I know a lot of us may be sitting there going, well, it's -3, but that's not the case. All right? Because you got to understand, you're subtracting using the place value method here. Just like, you remember a long time ago when we had a problem like this? Let's say 75 minus 16. 5 minus 6, you can't do that. You got to borrow because we're using the place value method. So we'd have to scratch out the 7, put a 6, scratch out the 5, put a 15. And then you could subtract this. 15 minus 6 would be 9, and 6 minus 1 is 5. So we're going to have to do the same thing here. We're going to have to borrow. Okay? So I know this 6 is going to turn into a 5. But the question becomes, what happens right there? What does that become?
Would it be 9?
Are you telling me that's how many we're borrowing, or are you telling me that the 4 changes into a 9, Todd?
I was saying like the 4 changes into a 9.
All right, I will have to disagree with you on that. All right? Anyone else? How about this? How about I tell you what it is? And then let's see if we can figure out why. I'm going to scratch out the 4. And becomes 15. Can anybody tell me what happened there? Remember, this was a 4. I scratched it out, and I wrote 15. I'll give you one more minute to think about it.
Add the whole number to the denominator?
Say that one more time, Jasmine.
Did you add the whole number to the denominator?
In a sense, yes, I did. So here's what happened, everyone. We started off with 4 objects in that numerator. We all on the same page with that? Okay, now, once we established we had to borrow, we scratch out the 6, and we put a 5. So in essence, we borrowed a total of 1. Correct? We dragged 1 over into our numerator. However, in this case, 1 is really 9 over 9. Because if you look at my denominator, that's a 9. So by borrowing from the whole number, we actually borrowed 1, 2, 3, 4, 5, 6, 7, 8, 9 objects. Because the denominator is a 9. Does that make sense? All right. So now we can go ahead and subtract. 15 minus 7 is 8. And 5 minus 3 is 2. So this is going to be 2 and 8/9. You have to be careful when you're subtracting with mixed numbers. And the reason for that is if you have to borrow, every time you borrow, every single problem will be different. All right? You will have a different amount that you're borrowing. All right? I think we need to look at another one like this. Okay, I think we need to look at another one like this. Oh, wait, didn't we just do this problem? Yeah, we just did this one. I'm sorry. Let's try this one. Four and 2/7 minus 2 and 6/7. First and foremost, denominators are the same. So my result will have a 7 for a denominator. Now let's look at the numerators. 2 minus 6. I got to borrow here. So I'm going to scratch out the 4. I put a 3. Now, what does that numerator become? Remember, you already have 2 objects to start with. And how many are you going to borrow now?
I'm going to go on a limb here. 7?
Yeah, that's exactly right. We are borrowing 7 objects or 7 parts. So this 2 turns into a 9 because 2 plus 7 equals 9. Remember, you look at the denominator, that's how many you're going to borrow. So now, 9 minus 6 is 3. 3 minus 2 is 1. Does that make sense, everyone? Okay? Remember, if you don't like this, you can always rely on your intuition. We can convert these into improper fractions if we wanted to. I'm going to do that right here. 4 times 7 plus 2 over 7. So let's see here. 4 times 7 is 28. And let's see here. 28 plus 2 is 30. So 30 over 7. 7 times 2 plus 6 over 7. So that's going to be 14 plus 6 is 20. So we can rewrite this as 30 over 7 minus 20 over 7, which is 10 over 7. And now we can go ahead, divide. 7 goes into 10 once with a remainder of 3. So you still get 1 3/7. I'm going to leave this up to you. I will never say do it this way and only this way. Okay? This is up to you. Are there any questions? All right, let's do one more like this, except let's get to the hard part. Eight and 1/2 minus 3 4/5. What do we notice?
Denominators are different.
I agree 100%. Denominators are different. Stephanie, was that you that gave me that answer?
Yeah.
How do you want to do this problem? Do you want to stack them and use borrowing if we have to? Or do you want to convert them into improper fractions and then subtract?
I would rather just convert them.
Okay, so we'll convert it and then I'll do it the other way for other people. So let's convert it first. I like that. 8 and 1/2. So that's going to be 8 times 2, which is 16, plus 1 is 17 over 2. Now we're going to do 3 4/5. So that's going to be 3 times 5 plus 4 over 5. 3 times 5 is 15, plus 4 is 19. All right. So we have 17 over 12, or I'm sorry, 17 over 2 minus 19 over 5. Step 1, LCM. Well, this is easy. 2 is already prime. 5 is already prime. So my LCM is going to be 2 times 5 or 10. I love it when the numbers are small. Step 2, build equivalent fractions. So we have 17 over 2. And our goal is to convert this to a new fraction with a denominator of 10. So I'm going to multiply this by 5 over 5. 17 times 5 is 85. Did I just say 17 times 5 or did I say 17 times 10?
17 times 5.
All right, just making sure. So 17 times 5 is 85. And then 2 times 5 is 10. For the second fraction, 19 over 5. So we got 19 over 5, and we want to convert that into a fraction where the denominator is a 10. So I'm just going to multiply it by 2 over 2. 19 times 2 is 38. So here we have 85 over 10 minus 38 over 10. So that's going to be our step 3, which is rewrite in simp. So 85 over 10 minus 38 over 10. So off to the right-hand side, I'm going to write 85 minus 38. I need to borrow. So that becomes a 7, and that becomes a 15. 15 minus 8 is 7. 7 minus 3 is 4. So we have 47 over 10. Now, if you want to, you can put a box around that. But you got to make sure you read the directions. All right? If they want a mixed fraction as an answer, you got to convert this. If it just says, give me a fraction, 47 over 10 is fine. But I'm going to go ahead and do it one step further. So let's go ahead and convert this into a mixed fraction, just so we have both answers. 10 goes into 47 4 times. When you subtract, you get a remainder of 7. So 4 and 7/10 is the final answer. Oops, sorry. Does that make sense, everyone?
Yeah.
All right. Now, I'll do it the other way, just so we can see it. So I'll stack them. And here's what's great. I could save myself a lot of work. And the reason why I'm saying that is because step 1 and step 2 doesn't change. All right? In other words, you need to find your LCM. It's going to be a 10. We need to build our equivalent fractions. So the only thing that we got to worry about, and I'm going to do it off to the right-hand side in this red box. Is we just got to build these little equivalent fractions real quick. We know what the LCM is. It's going to be 10. So I just need to multiply this one by 5 over 5 to give me 5 over 10. And then the second one multiplied by 2 over 2 to give me 8 over 10. So I'm going to get 8 and 5/10 minus 3 and 8/10. From here, we know denominator stays the same. 5 minus 8, I have to borrow. So I scratch out the 8. I put a 7. I had 15, but I borrowed 10 because of my denominator. So this is going to be 15. And when you do the math, 15 minus 8 is 7. And 7 minus 3 is 4. Same exact answer. I know a lot of us, Stephanie in particular, may like the convert to an improper fraction.
Yeah.
I like doing it this way, which is just stacking them and borrowing. To each their own. To each their own. All right. Are there any questions? Are we sure? Autumn, you good? All right. I got a thumbs up, so I like that. All right. So since we're in this business of converting from mixed numbers into improper fractions, I think this is a good time to transition back to 4-3, which is multiplying and dividing mixed numbers and complex fractions. So we got the hard part of the class over today. It's over. Here comes the easy part. I need somebody to remind me. How do we multiply fractions?
With a calculator.
No, Zach. How do we multiply fractions?
First we write the first fraction same. Then we reciprocal the other the second fraction.
All right, Asma, you're telling us how to divide fractions.
Oh, sorry.
You're okay. You're okay. That's still good. That was going to be my next question. How do we multiply fractions? That was a couple classes ago.
So, if I can remember, if both fractions are not equal, then I think we split them into the common factors.
Okay. So, Todd, you're there.
First we simplify.
Simplify first. And how do we do that, Todd?
Prime.
Using prime factorization.
Yes.
Step 2.
Multiplying.
I'm gonna be a little bit more descriptive here. Step 2, we're going to use the property of 1. In other words, if you see a number divided by a number and they're the same, just scratch it out and make it a 1. And then, like Asma said, we're going to multiply what I like to call the leftovers. In other words, any numbers that you couldn't simplify. All right? Stephanie, you're going to love this.
Why?
Because our first example, 3 1/3 times 5/8. To simplify this, or I'm sorry, to multiply these two fractions, you were forced. We have to convert this. That's the only way to do this. So if you were given a mixed number, you got to first convert it into an improper fraction, and then you follow the 3 steps that we have outlined here. So let's go ahead and do that. So 3 1/3. I'll write it off on the right-hand side of the screen. It's going to be 3 times 3 plus 1 over 3, which is going to be, 9 plus 1 is 10. So we have 10 over 3 times 5 over 8. Now we multiply. So step 1, simplify using prime factorization. That 10 is 2 times 5. The 3 is prime. That 5 on the second fraction in the numerator is prime. And 8 is 2 times 2 times 2. So there's step 1. Step 2, we're going to write one big numerator and one big denominator. And we use that property of 1, meaning if we see a number that's the same in the numerator and denominator, you reduce them and you replace them with a number 1. So, if you're watching on the screen right now, I can reduce a 2 in the numerator and a 2 in the denominator, and that turns into a 1. Now, are there any other numbers I can do that with? No. So not only is step 2 done, but I also know whatever this happens to be is already a reduced fraction. And it's because I just did it right now. So step 3, 5 times 5 is 25. And 2 times 2 is 4, times 3 is 12. The only thing we need to be careful of is the directions. If they want an improper fraction or just a fraction in reduced terms, 25 over 12 is fine. If they want a mixed number, then we just got to do one more step, which is convert it back into a mixed number. 12 goes into 20. Oh, sorry, I wrote down the wrong number. 12 goes into 25 twice with a remainder of 1. So it all depends on what they want. It's kind of like going to the store. If you go to Best Buy because you want to buy a computer, and it says it's $1,000, and it says, well, we'll keep it simple for math purposes. Let's say the computer is $600. All right, or $650.
Cheap computer.
I know, right? So let's say it's $650. You hand the cashier $700. You are expecting $50 in return, not bottle caps and nickels. All right? In other words, you expect an answer, or you give, and then you expect the result in the same format. So if the problem says, give me a mixed number, you got to do a mixed number. If they want just a fraction, just make sure it's reduced. All right? Are there any questions with that? Well, I got to be honest with you. That is section 4.3 in a nutshell. Multiply and divide is very easy. The only problem is you may have to convert things first, and you have to do that. With adding and subtracting, you got options, but here, you have to do it. So let's go ahead. Let's try another problem here. Actually, I want you to do this one. So we have 2 4/5 times -1 7/8. Remember, you are forced. We need improper fractions here. So please convert these and then follow your steps for multiplication. Did anybody get an answer yet?
I did get one that isn't a mixed number.
Okay, that's fine. Sometimes the answer may not be a mixed number, and that's okay.
Well, I have an answer, but I haven't like finished figuring out a mixed number.
So, are you telling me you got a mixed number as an answer, or you didn't?
Forget it.
Well, no, I'm just confused.
So, I have an answer, but it's not a mixed number. But I haven't finished dividing the fraction into a mixed number.
Okay. So, in other words, you need some more time.
Yeah.
Okay.
Mr. Flood, I got a question.
Go for it.
If we have you for this math, is it like a higher chance we'll have you for next semester too? Or
No. You have to pick you got to pick your classes. So, Zach, I will answer that question in a minute. How about that?
Okay.
Okay? All right, so let's do this problem because it's 10:49. All right, so here's what we got to do first. We're multiplying two mixed numbers. We have to convert. So, 2 4/5 as an improper fraction. So, 2 times 5 is 10 plus 4 is going to be 14/5. So, I write that directly underneath. And then the 1 7/8, I'm not going to worry about the negative sign. I'm just going to put it over here because I know it's a negative fraction. So 8 times 1 plus 7 over 8. So that's going to be 8 times 1 is 8 plus 7 more is what? 15 over 8. So question, are my conversions correct first? Correct? I see Robert saying yes. Anybody else agree?
Actually, for one for 1/7/8, I actually like added the minus into like 8 plus
Okay.
times
And
1 plus 7.
okay, Todd, and that
So
you got to be careful because that's incorrect. Remember, this negative sign just says that the fraction is negative. All right? So you got to be careful with that. All right? The only thing we're converting is the fraction, not the negative sign. Because technically, Todd, it's really -1 times 1 7/8. All right? So the only thing you're converting is the 1 7/8. All right? So be careful with that. Any questions with that so far? Very common mistake. Just be careful. All right. So now we're going to go ahead and follow our steps for multiplying. Step 1, let's go ahead and prime factorize everything. 14, 2 times 7. 5 is prime. Put a negative sign. 15 is 3 times 5. And 8 is 2 times 2 times 2. So now I'm going to write one big numerator with a negative sign out front. 2, 3, 5, and 7. And then one big denominator. And the only thing I have to do is just simplify using my property of 1. 2 over 2. And 5 over 5. For a final result of negative 21 over 4. That's our improper answer. Our mixed number answer, and be careful, you are only dividing 4 and 21. So 4 goes into 21 5 times. So your mixed number answer is going to be -5 and 1/4. Okay? Are there any questions with that? All right. So Zach had a question earlier, and I think it's a pretty good one because maybe some of you don't even know that this is going on right now as we speak. So what I'm going to do is stop the recording.